Hello everyone, welcome back to the channel. In today's video, we explore the idea of how a simple model development AI agent can assist people in quantitative research and improve efficiency. Note this exploration is purely for academic purpose and personal interest. The demo leverages Google Gemini Command Line Interface or CLI. We will first give a brief overview of what capabilities the AI agent has. We will then review what the AI agent does in each of the steps and what type of configuration the AI agent needs. The simple model development AI agent can perform model proposal analysis based on user requirement, with the ability to cross-reference user-provided reference model publication. Based on Gemini's internal training knowledge or the reference model paper, the agent proposes a mathematical solution to the user for review. Once the user confirms the approach, the agent implements model code and test cases. The agent runs through all the test cases and records results. And finally, the agent will produce a standardized model document, capturing user requirement, methodology approach, model assumptions and limitations, input data used, test cases, and testing results. The agent also has capability to connect to a repository such as GitHub and commit relevant model artifacts for future use or review. The agent is set up with a three-step workflow internally. Step A, requirement analysis and model implementation. During this step, the agent analyzes user requirement or reference research paper, proposes mathematical solution, and implements model code once user confirms the proposal. The agent's system instructions are set up with this template. First, it requires a trigger from user prompt to instruct it to execute this step. Second, in the requirement analysis and model research section of the template, the agent is set up with instructions on how to understand data sources, analyze user requirement, utilize reference paper to derive methodology details and proposal. Third, the agent is further instructed on how to make the proposal, including the consideration of model assumptions and limitations. Lastly, the agent is instructed how to implement the model code, including potentially coding style and design, or consideration of edge cases. Step B, testing and model documentation. Here the agent is equipped with flexibility to load standardized tests from built-in testing library. Based on model type supplied from Step A, user can also supply customized test requirements. The agent combines standard tests and user custom tests and presents final testing plan for the user to confirm. It then implements test code for all the tests and executes through them. After all the tests are completed, the agent produces a standard model document combining methodology detail, data input, user context, model assumptions and limitations, and testing results from Step A and B altogether. Similarly, Step B agent config follows a templatized setup. The trigger guides the agent when to get activated. Testing plan section instructs the agent how to load standard tests and integrate with user-defined custom tests. The test coding and execution section instructs the agent how to generate testing code and execute the tests. And lastly, the model documentation instruction guides the agent how to generate a standard model documentation covering all the critical components from Step A and B. Step C, model repository integration. The agent is set up to integrate with GitHub in this demo. Technically, you can build this agent to connect to any repository you use, assuming Gemini supports such integration. It handles nuances such as local versus remote branch creation and synchronization. It also supports model artifacts identification and bundling, for example, whether data or image should be uploaded. Step C, agent's configuration template covers below points. First, the same trigger mechanism to execute this step. Second, instruction on how to identify the repository setup. Third, handle branch creation, deployment of model artifacts. Fourth, identify what model artifacts are subject to repository deployment. Now let me do two demos to show how this agent works in practice. In the first demo, we show how the agent references a user-supplied research paper to build a credit default loss model. Here's the public research paper used in this test. Here are the user requirements captured in a standardized template, which is consistent with the AI agent's system instruction configuration. The highlighted sections such as model name, model type, business objective, data requirement, model technical requirements are used by the agent to perform Step A and B. The custom test file captures custom tests that the user would like the agent to perform. The test results will be included in the model documentation. These are the input files to the model. The agent needs to understand the input data structure when it builds the model code and model testing cases. Now we will launch Gemini CLI to run this test case. Note you need to install and activate Windows Linux subsystem before running Gemini. Now let's enter the instruction for the agent to run Step A. The key highlight in this instruction is we ask the agent to prioritize the user-supplied paper to derive the modeling approach. We tell it to generate the code in a Python file called credit default model. We also let it know what input files the agent should use. The agent takes the instruction and starts to crunch through details. The agent understands that the reference paper I supplied is from the internet, so it pulls it from the URL. It then goes on to summarize the mathematical approach after analyzing the paper. Note: given I am running the demo with Gemini CLI as a chatbot, Gemini will ask me to confirm action anytime it writes to a file or executes some shell command for extra safety. There are ways to suppress such confirmation if you have an agent that's very well tested, so you can fully trust its internal decisions. Now step A is done, the model code is created. I can now enter instruction for step B. The instruction asks the agent to combine standard and custom tests for my review before executing. It also tells the agent what input files to use for testing. Now let's run. The agent compiles the stand tests and custom tests and present them for review. Once I let it proceed, it generates the model code and start to run through the tests. Note: given this model requires Monte Carlo simulation, the tests can run for a long time. Gemini command window may get timed out depending on the test runtime. In such cases, the agent requires additional setup to handle running the tests as background process and requires additional polling mechanism to wait for the test completion. This is more advanced concept, so we will not demo that in this simple setup. Now all the tests are done, the agent goes on to generate the model documentation. Step B is now successfully completed. For step C, I instruct the agent to find out my GitHub repository information, create a branch called Research Credit Default Demo, then upload all the model artifacts. After running through the relevant Git commands, this step is also completed. Through this process, you can see I didn't have to interject anywhere in between, except review and confirming the agent's request. Now let's see how my GitHub repository looks like. The credit default demo branch is created, and within the branch, I can see all the model code, model documentation, testing folder, requirements, input data, testing code, image outputs successfully uploaded. Looking the model code, it looks pretty comprehensive, covering all the requirements we provided. The model documentation is generated with a standard format, covering model purpose, model methodology, data input, model assumptions, testing approach and result, and model limitations. You can see with a simple AI agent's help, the model research effort is greatly improved. In the second demo, we show how to use the agent to build a Nelson-Sagel yield curve model. This is a fairly standard approach to model interest rate, so we will test the agent's pre-trained knowledge. The user requirement is captured in the same standardized template as the first demo. The highlighted sections such as model name, model type, business objective, data requirement, model technical requirements are used by the agent to perform step A and B. The custom test file captures custom tests that the user would like the agent to perform. The input data file contains underlying interest rate contracts that the model needs to bootstrap the yield curve. In step A, we ask the agent to build the Nelson-Sagel yield curve and generate the model code to yield curve model Python file. We instruct it to use data CSV file to bootstrap the rate curve. The agent thinks about what it needs to do based on internal training and then start to develop the model code. It also presents the mathematical formula as it completes step In step B, the agent is asked to perform both standard and custom tests associated with the yield curve model. It also needs to generate the final model document when all the tests are completed. The agent loads both the standard and custom tests and presents a combined test plan for me to sign off. Once I give the go-ahead, it starts to code the test cases and execute them. As all the tests are completed, the agent goes on to generate the full model documentation. Now step B is also completed. Lastly, the agent is instructed to upload all the model artifacts to GitHub. After running through repository discovery, it goes on to create Git branch to push the files. Note the agent can self-resolve simple duplicate branch issue and correct it without my intervention. After running through the full set of Git commands, the commitment is completed. Now in the GitHub repository, I can see all the model documents, code, data, including tests and images are all uploaded as instructed. Similarly, the model code is fully implemented, along with relevant testing code. The model documentation follows the same standard template, including the model purpose, methodology, data inputs, assumptions, limitations, and the testing sections. The various test cases and results, including the images, are all presented in the model document. We've now shown what the model development AI assistant can do. So what's the next step? The agent demonstrated is a simple chatbot-based agent. It may act as a junior developer to assist new quantitative research effort, but it is not capable of performing end-to-end model development, project management, and model review processes. For anyone who's interested in building on top of this demo, here are some ideas. In real-world quantitative research process, the agent will likely need more flexibility to handle user requests on demand and remember past development context. It will also need better flexibility to support dynamic change management, where material change in model inputs or parameters should automatically trigger performance testing and documentation update. For example, when some stress event is happening in the market, the user may have the desire to trigger the agent to rerun certain tests or handle some new tests. Thirdly, the simple agent does not handle long-running model testing well. A more complex agent is needed to handle such run-through background processes with callback to the agent, so it can either notify the user of test completion or resume the next step. If the researcher needs to periodically retest certain parts of the model based on new data arrival, for example, new GDP data or new stock price time series, the agent framework should have notification mechanism to notify and trigger such recurring tasks. The fifth enhancement is it may be beneficial to integrate the agent framework with project management tools so model development plan can be effectively managed. And lastly, it can be desirable to introduce peer review capability for research collaboration. Leave feedback in the comments section on how you would suggest further enhancement to this demo or any other idea you would like to see a demo for. See you in the next video.
See you next time. Bye.